Hi, Physics 1 students. Welcome back to Block 6 of the material. Today we're going to look at collisions. This is part 2 of Block 6. And there are various things that we want to accomplish throughout this discussion. First of all, we want to be able to discuss the difference between constancy and conservation of linear momentum. So to do this, of course, we'll set up various examples and work through the mathematics. But in the process, we hope to get a better understanding in each of these examples as to what we mean by constancy versus conservation of linear momentum. Another thing we want to accomplish is to describe the conditions under which linear momentum of a system is approximately constant. So we want to be able to look at a particular scenario, a physical process, and of course, the main goal there is to understand exactly when momentum is constant during the process and when it is not. We want to be able to use constancy of linear momentum to determine the initial or final momenta of a system of colliding objects. So to be more precise now, we would set up a particular example where we have various objects initially with various momentum values, and there's a collision that takes place, and then we have a final situation where the same objects are present and they all have different momenta in general. And we want to be able to set up equations based on our understanding of the physical concept and be able to solve for particular unknowns. So the fourth thing we want to do is describe what it means for a collision to be elastic, inelastic, or perfectly inelastic. So these terms refer to kinetic energy throughout a process. And so besides just learning terminology, the main point of this is to apply these in particular examples. Fifth, we want to determine whether a collision is elastic, inelastic, or perfectly inelastic. So the terminology again, understanding what it means, the terms mean, and then applying them effectively to solving particular problems. Finally, given a 1D elastic collision, we want to be able to apply the impulse momentum theorem and the one-dimensional elastic collision condition, which we'll see what that is, to determine unknown velocities or masses. So as in all the physics problems we've done to date, part of physics is understanding the concept and of course the physical situation, and then being able to extract or apply mathematical rules to be able to come up with various equations so that we can solve for unknowns. So let's look at this warm-up question before we get going. So two planets collide in deep space. If we define the system to be both planets, that's both planets together, which of the following quantities can change during the interaction? So the momentum of the system, the translational kinetic energy of the system, the total energy of the system, or more than one of these, possibly. So just take a moment and think these over, and we'll be right back to discuss them.